Alright, let's see if we can go through a quick video getting this to work. Quit 3 windows. Oh, no, looks like it's working good. Alright. So one of the things we talked about on the last test was the law of conservation of matter and mass. Mass is the measure of matter in grams, and here we had an example problem of hydrogen gas reacting with oxygen gas producing water, and 3.4 grams of hydrogen gas is going to react with some amount of mass of water of oxygen to produce 13.4 grams of water. Question is, how much? Well, this is our final mass. The starting masses combined together must equal the final mass. So the answer to this one was 10. So if we wanted to copy this guy here and bring it over and type 10 in the box, that would be the right answer. So 10.0 grams. There we go. And when I started this, I said we're not just talking about the law of conservation of mass. There's matter, which the mass is the measure of that matter. We typically represent matter being conserved by atoms. Atoms coming in and atoms coming out of the chemical change. So here we have the starting chemicals, and here we have a final chemical. And if you look at your starting chemical, you have 2 red atoms, which represent 1 oxygen molecule, and you only have 1 red atom here. So I went ahead and copied this water molecule, and I am bringing it up there to show that we are now conserving 2 red oxygen atoms. And now we have 4 white hydrogen atoms and 2 white hydrogen atoms. So I'm going to go ahead and conserve those 2. So what I'm going to do is I'm going to print screen and copy this little guy to give me 4 hydrogen atoms coming into my chemical change and 4 coming out of my chemical change. And that's how you would do that. Now, I'll do one more example problem for this video. Methane, CH4, which you can go to molview.org and type in CH4 and then press enter. And you get the structure of methane. At least you should. I might need to refresh here. So let's go CH4. Uh-oh, there's a problem there. Let's see what the drop-down box gives us. Let's type in methane. There we go. There's methane. So I'm going to go ahead and copy that. That's one of the chemicals that we need. And go back to your screen. I had already copied this from another earlier video I tried to make but failed at making. And shrink that guy down so it fits. And there we go. There's our methane, CH4. Now we're going to need an O2, which again you can go to molview.org and just type in oxygen. If you're doing like me and using Google Slides to do this, there we go. I had to set this picture to go to the back in order for it to reveal the molecular oxygen there. Here's a carbon dioxide, which again, if you go to molview.org to make these, you can just type in oxygen. Ah, that's definitely not oxygen. Oxygen. There we go. There's our oxygen. I've already copied those here, and carbon dioxide, again, carbon dioxide. Don't click the thing below it, just press enter when you're done typing it, and it usually gives you the structure you want. And here's carbon dioxide. I'm going to go ahead and bring that guy over here. And then we need another water. So here's our water. I'm just going to drag it. Now we have 2 red atoms coming in and 3 coming out. And we have 4 white atoms coming in and 2 white atoms coming out. So I'm going to double the water to balance those white atoms. And finally, now we have 4 oxygen atoms. We need to show the conservation by doubling the oxygen atoms. And there we go. So now we have 4 red oxygen atoms coming into this chemical change, 4 red oxygen atoms coming out of this chemical change. So yay, our law of conservation of matter is being represented quite accurately. But what about the mass part? So we have 20 over here, but we're missing the mass of CO2. 10 plus 14 is 24. 24 plus 2.2 is 26.2. That's all of this together is 26.2. So what's 26.2 minus 20? It is, oh, that's funny, I forgot I had already made a box for this over here. But regardless, it's 6.2 grams. So now we have 26.2 on the right and 26.2 on the left. And we are showing the law of conservation of mass and the law of conservation of matter, which are actually the same thing, being fulfilled. Now keep in mind, the universe does not care if we did this problem correctly or not. The law of conservation of matter says that if you burn a candle flame, it's going to do its chemistry based upon that law, whether you know how to do it or not. So this is us just understanding that when methane burns with oxygen, it uses 2 oxygen molecules and 1 carbon dioxide molecule is produced. That's our new chemical, definitely indicating a chemical change. And it produces 2 water molecules. So that's a good stopping place. If you wanted to finish all of this and check your work, remember on the next slide I worked all that out for you. So if you wanted to use the video to kind of go back over that or not, you very well could. Just go back and forth between the picks. Alright, that's about all I got for this video. Let me stop recording.